In mathematics and physics, we'll often come across problems which require us to resolve the value of a vector, such as a force, velocity, and so forth, in two planes. I'm going to work through how to resolve the value of a vector in two planes. We've got this example where a projectile is thrown at an angle of 12 degrees at a velocity of 10 meters per second. And the question requires us to find the maximum height which is achieved by this projectile. In order for us to do that, we need to be able to determine the velocity at which the ball is traveling vertically as well as horizontally. For us to do that, we need to split that 10 meters per second into its vertical and horizontal components. And we do that using trigonometry. We use three trig ratios: sine, cosine, and tangent. A simple way to remember our trig ratios is to use the mnemonic SO katoa. So, ka, toa. Toa. So is sine. Sine is equal to O representing opposite and H representing the height. Cosine is equal to the adjacent over the height. Tan is equal to opposite over adjacent. So we're going to use these trig ratios to determine the velocity in the vertical plane and the velocity in the horizontal plane. Our velocity, 10 meters per second, is at an angle of 12 degrees to the horizontal. So for us to find the component in the horizontal plane, we need to use our trig ratios. And remember, given our triangle, and that is our 12 degrees, that's our height, that's our opposite, and that's our adjacent. So to find the component in the horizontal, our horizontal would be our adjacent. So which trig ratios do we use? We use our cosine, which is adjacent over height. And we know our height represents our 10 meters per second. Therefore, our component in the horizontal, cosine of 12 degrees, is equal to our adjacent, which is the value we want to calculate, over our 10 meters per second. Our adjacent therefore becomes 10 meters per second cosine 12 degrees. A simple way to remember this is that C represents close to. So cosine is always used to find the value of the component close to our angle. So that is our horizontal component, and that is our vertical component. And you can see that the 12 degrees is close to our horizontal. Therefore, we know it's 10 C for close to 12. Our adjacent, which is our horizontal component, becomes 10 cos 12. If we wanted to find the vertical component, that vertical component on our triangle would be there. That would be our vertical component. But given that it's a triangle, let's complete that and make it a square. You can see that that side and that side are equal to that side and that side respectively. So we know that the component of our force in the vertical should be the same as that size there. Right? So effectively, it's our opposite. Right. We want to find the value of our opposite, and we make use of our trig ratio sine. Sine equals opposite over hype. We're working with our angle of 12 degrees. So sine 12 degrees is equal to opposite over 10 meters per second. So the value of our opposite then becomes 10 sine 12 degrees. Our vertical, which is our opposite, is equal to 10 sine 12 degrees, and our horizontal is equal to 10 cos 12 degrees. Remember the direction in which the velocity is traveling. You can see that arrow is pointing upwards to the right hand side. So that horizontal component should point to the right hand side, and that vertical component should point upwards. Once we've done this, we've resolved our velocity, and then we can move to the next step of solving our problem.